Hi guys, my name is Victoria Moe and this is Nursery Smiles. So the problem. A few months ago I spoke to Mimi, a caregiver at a nursery in New York called Smarter Toddler. She and all of the other caregivers use pencil and paper to record the daily child reports and to communicate with the parents. However, she complained to me that creating, printing out, writing on, and keeping track of the stacks of papers takes a lot of time, especially with the young toddlers often losing or eating the documents. On top of that, the administration always wants to know what goes on in the classroom, and the parents are always demanding more information about their kids. Keeping the adults updated is a full-time job in itself, but really all Mimi wants to do is to focus on the children. Next, I spoke with Adam, a classmate of mine with two children, a 2 and a 10-month-old. His kids are too young to tell him what goes on during the day when they're in daycare, so he has to rely on caregiver reports to know what his kids have been up to. However, when the reports do make it back in one piece, they are stuck onto the fridge for a day or two before ending up in the recycle bin. What Adam wishes is that he could look back on his kids' development and that the caregivers would take more photos and videos of his kids. Now, onto the product. So, the basic idea of Nursery Smiles is that it digitizes and simplifies all nursery parent communication that currently takes place using pencil and paper. You can think of it as a parent portal for parents of young toddlers. There are two components to the product: an iPad app that caregivers use to record child information and to send reminders, and an iPhone app for parents to receive real-time notifications and to view the data. Now for a demo. First, the caregiver selects the class and the kid or kids to update. Here I show the process of taking a photo using the application. The reason being that parents love photos and videos about their kids, and by recording with an iPad, the caregivers can more easily accommodate this demand without breaking their flow in the classroom. Now, the parent, although he or she may be miles away from his or her child, receives a phone notification to view the newly updated information. Also, the parents can view the history of events so that they can better understand how their child is developing. Next, I will go over how I modeled my data. The first tables that I created are these basic tables that model the kids, parents, teachers, schools, classes, and kid reports. As you can see here, each kid can have many reports, and each school can have many classes. However, there are many relationships between the kids and the parents, the kids and the classes, and the classes and the teachers. These many-to-many relations are then expanded to denormalized tables. Although I avoided doing extreme denormalization by only keeping the data that is necessary for the queries being handled by each column family. For example, for the parents of kids, while the parent's name may be important, for example, for sending out an email to that parent, there is no reasonable query to parents of kids that requires information about the parent's password. Similarly, for classes of kids, the time frame of a class may be helpful for distinguishing between classes, but the maximum age of a class would not likely be useful for that type of a query. Here is an example query for a nursery caregiver. She would sign in, select from her list of classes a class to update, select the child to update from that class, and finally create a new update for that child. In this case, it is reporting a wet diaper with cream added to the child's bump. On the parent's end, the parent would sign in, select the child whose report he wants to see, and then select the class name filtered by the type of updates to view the desired information about his kid. Finally, I will go over my experience using Cassandra. My very first impression of Cassandra was that the syntax was much more like that of a relational database, although it acts much more like a key-value store. Therefore, it was very simple to pick up and learn the basic SQL commands. Some differences that I noticed included the difference in querying non-primary key columns, and for those cases, I had to create secondary indices. Also, auto-incrementing an ID to create unique identifiers in a distributed environment like Cassandra is very costly. So in the case of classes, I used a school name and class name, and in the case of kids, I created a UUID to create a unique ID for each child. Finally, I found it to be more true in Cassandra than any other database language, the importance of having each potential query handled by a single column family. Whereas I could use joins freely in a relational database, in Cassandra I had to be more careful about thinking about all possible queries up front. Initially, I was hesitant to create extra tables for denormalization, but after reading about best practices and trying it out for myself, I realized that denormalization is really the way to go when working with Cassandra. Finally, I would like to thank everyone at DataStax, especially Brady and Patrick, for answering my questions and for guiding me through the adventure of learning Cassandra. Thanks for listening!